Okay, I wrote this problem last year, and then I realized it had a problem, and then I said I was going to fix it, and I didn't fix it, and then last semester I tried to use it, and it's like, oh yeah, this one has a problem, and this time it's like I remembered it had a problem, and I thought I fixed it, but I did not fix it. So the problem as written is not very good, but I'll change it up. So let's change it. Forget this part right here for right now. Just forget that part. So consider a 4-bit register using D flip-flops. So however many bits your register is, that's how many flip-flops you're going to have. They're usually going to be D flip-flops because they're the ones that work nicely for registers. And usually with these kinds of questions, you have that they have a choice of things that they can do. If there's a choice of things that they can do, that means that you're going to have a multiplexer. If there's only one thing that it does, like if it just says the values shift left, well, that means that the output from this register becomes the input for this one. It's going to the left. The output for this register becomes the input for this one. The output for this register becomes the input for this one, and then depending on the problem, you might have a different input coming in to the last register and this output going nowhere, or you could have this one kind of circling around and being the input to that one. So that would be shifting left. If you needed to shift right, then the output from one register would go to the one to the right. And these are numbered 3, 2, 1, 0. But if you have more than one thing that you can do, you're going to have a multiplexer that's going to tell you which of those things you're going to do. So in this one, we do have a choice of what we're going to do. So we'll have multiplexers. Those are the worst multiplexers I have ever. Well, no, I can draw bad ones, but thank you, OneNote. Okay, so here are my multiplexers, and the reason I know I'm going to need a multiplexer is I see this word if right here. If the variable named signal is 1, so I've got a variable called signal, that's going to be my input into my multiplexers. And if it is 1, that means we're going to be putting things into the one input right here. My multiplexers, the output of the multiplexer is the input to the flip-flop. Okay, so if the variable named signal is 1, the register should shift values right using the serial input left in as the input for register 3 and serial output right out as the output for register 0. Okay, let's worry about just this first part here. Should shift values right. So that means if we're talking about signal being 1, it's going to shift right. So right is this direction. So the output from this one is going to go to the input for this one. But the input for this one is a multiplexer because the input depends on whether signal is 0 or 1. We're talking about right now when signal is 1, so it goes into the 1. So shifting to the right, the output from 3 goes to the input to 2. How does it do that? Well, it's only if signal equals 1, so it goes to 1 of the multiplexer. 2 goes to 1. 1 goes to 0. What do we do with 0? Well, 0, now we're going to look at the other information. Serial output right out as the output for register 0. So this is right out. And left in as the input for register 3. It could have told us that the output from register 0 is the input for register 3, but that's not what it told us. Okay, so that is if signal is 1. If the variable named signal is 0, the register should load the AND of WI and QI into the ith register. So I've got another variable, W, and W is a vectored signal. It has the values W3, W2, W1, and W0. And we're supposed to AND together the WI with QI. Well, this is Q3, this is Q2, this is Q1, this is Q0. So I'm going to AND together W3 and Q3, and that'll be my input into the 0. So here's W2 and Q2, and those together. W1 and Q1, and those together. And W0 and Q0, and those together. Draw this register. I did. Yay. All right. So now this part that was in parentheses, it says and parallel output Y03. I'm calling it by two different names here, and so that's a little confusing. Just don't worry about that. So just take that out. And this isn't really an input. It is an input, but it's not. It's just part of the input. It's being ANDed together. So I would say just ignore this line. Okay, now how are we going to write Verilog code for this? So let's do that. Okay, so our inputs we had write out. Alright, that was an output, but our inputs were W left in. Let's see. We have signal. It doesn't say when it should do this. Let's do this on the positive edge of the clock. So let's have a clock. And let's have our output. Do you want to call it Q or Y? I'll call it Q. Will be our output. Okay, and so then we'll have input. We have left in, clock, signal. We have output. We're going to change it in the always block. Output reg 3:0 Q input 3:0 W always at pos edge clock begin. I don't know if I'll have more than one thing in here. If signal, so that's the same as saying if signal equals 1. Then what did we say? We said, oh, this is going to have a begin and an end because we're doing different things. So we'll have begin. And I'll need to put an integer in here because I'm going to need to have a for loop. call it K. For, now let's look at our diagram that we made. We went, so we had three went to 2, 2 went to 1, 1 went to 0. So we defined the inputs for 0, 1, and 2 based on the one that came before it. So 3 went to 2, 2 went to 1, 1 went to 0. So I want to do a for loop that goes from 0 up to 2, and then I have to do something different to get my input for 3. Trying to remember if it's semicolons or commas. It's semicolons. Okay, so what I'm going to do here is I am going to say that Q of K, I use a non-blocking assignment. That's because I want it to use the value that we had when we came into the loop. We don't want it to change based on an updated value. So Q of K becomes equal to Q of K plus 1. This should have been just K less than 3, not less than or equal to 3. I only want to do 0, 1, and 2. So Q of K becomes equal to Q of K plus 1. And that's the only thing in my for loop, so I don't have a begin or an end for that. But then I also am going to say that Q of 3 becomes equal to left in. And that's the end of if signal equals 1. Else, we had that Q, we'll have another for loop for K equals 0, K less than 3, K equals K plus 1. And we're going to have Q of K equals W of K ANDed with Q of K. Now notice here I need to make this non-blocking. Actually it wouldn't make a difference on this one. Okay, so we've got that. And then the last thing we need is, I needed up here to have write out. So write out then becomes a reg. So output reg write out. Write out becomes equal to Q of 0. I left that part out. End the always block. Didn't actually need to end I didn't actually need to begin and end for the always block, because the always block as it is just has an if-else. So it has one statement, an if-else. Now the if here has multiple lines, so it has a begin and end. The for only has one line, so it doesn't have a begin and end. And this for only has one line, so it doesn't have a begin and end. So that's that. And then an end module. Okay, a couple things I see I did here. This should have had a semicolon. And this, I called it a CLK up there, so it should be a CLK there. Alrighty.